In 7.3, we're going to be focusing on rotations, a type of transformation that is an isometry. Remember, an isometry is where length is preserved. Okay. In a rotation, it's very important to know where the center of the rotation is and the angle that of the rotation. So, for example, here might be an image, and I might be rotating it about this point right there. So this would be the point of rotation, and the angle of rotation would be this angle here. For example, if I'm going to rotate it, say 60 degrees, I might end up with a square that looks more like this. Okay, I'm going to rotate this point. This point's going to get rotated at the same angle, but this would be so connecting from the center rotation to a point on the pre-image to the image. Okay, so we'll call this point A. This would be A prime. You rotate it 60 degrees counterclockwise. Now we're going to do some rotations, and we want to notice the angle is listed and the point of rotation is listed. So now I'm going to plot the points for the pre-image. 2, -2, 4, 1, 5, 1, and 5, -1. And I probably should have put B a little bit higher. This should work out a little bit better. Alright, so here's B, C, and D. So I want to rotate this 90 degrees. Which way? Clockwise. So I want to rotate it down this way 90 degrees. About this point right here, the origin. To do so, one of the things I like to do is imagine if I want to rotate this 90 degrees, I'm going to kind of visualize this little triangle. Okay, it's easy to rotate things that are parallel to these lattice lines. So if I want to rotate this line 90 degrees, it's going to go, and we're doing clockwise, so it's going to go up to here. So this point is going to go over, this line is going to go over like that. This line was going this way, so now it's going to go down. And now this line is the one that I actually wanted to rotate. And this would be my final point, A prime. That's where, here's the image, pre-image, here's the resulting image after the rotation. I'm going to erase some of these marks so I'm not confused by them, and I'm going to do the same thing again, this time with point D. So I kind of draw in a little triangle, and I'm going to rotate this side that is touching the origin 90 degrees. So if it's down here, it's going to go over like that. And then this side was over 1, 2, 3, 4, 5. Well, now if I spin this up, this thing's swinging this way, I got to go down 5. 2, 3, 4, 5. And that's going to be my resulting point, D prime. So I can connect that point, and I successfully rotated that. Maybe I need to do probably B still in here. So rotate another point. B is drawing a triangle where it has one of the X or Y axis as a side. Now when I spin this one 90 degrees, it's going to go down to 4. 2, 4, and it was going up 1, so now this part is going to be to the right. So this is going to be B prime. And now can we figure out where C prime is without actually rotating it? Imagine this thing. This is basically a right angle between D prime, B prime. Oh, I shouldn't have. I'm going to undo that. I made a mistake. I'm looking at where to put that. C prime needs to be down one further. I was going to think putting it up here, but that's not in the right order. So here's C prime, B prime. And now I have my resulting image. I might come back to this in a second. Let's see what my next page shows. Yeah. Sorry about that. Notice, yeah, here it is. I knew it was somewhere. This is very important. Make sure you get this in your notes. You can do this a lot easier with some notation. We're going to say the point xy. Let me just get rid of all this. I think these got put in the wrong spot. If we want to do a rotation, we can do it in a different, using an XY coordinate notation. Notice the point A was at, let's pick a different point. The point D here was at 5, -1. And D here was at -1, 5, -5. Notice same numbers, right? I'm going to clean this up. -1, -5. Same numbers almost. And if you look, your x coordinate went into your y coordinate spot and became negative. And your y coordinate just moved into the x coordinate spot. That's what, when you do a 90-degree rotation, that's what happens to your coordinates. So for example, C here is at the point 5, 1. If you put 5 in for x and 1 in for y, it's going to flip so that the 5 goes into the y coordinate spot but becomes negative, and your y coordinate moves into your x coordinate spot. So I'm going to say C prime should be at 1, -5, 1, -5. There's C prime. We could do that again with A prime. A was at 2, -2. So 2, -2. This arrow means gets mapped to. 2, -2 gets mapped to. We're going to flip your x and y coordinates around, but your x coordinate is going to, when you flip it over here, it's going to become negative. So this was a 2, so now it becomes a -2, and your y coordinate just moves over here. So it didn't change. So A prime should be at -2, -2. For a 180-degree, for a counterclockwise rotation, we're going to be going the other direction. If I was going to rotate B, which is at 4, 1, counterclockwise, it's going to end up over here, right? Imagine this triangle. This blue line goes up here. It was up 1. As it spins, it's going to go over 1. So B prime ends up at -1, 4. So a counterclockwise rotation, notice your x coordinate moved into your y coordinate spot, your y coordinate moved into the x coordinate spot, but became negative. And for a 180-degree rotation, Okay, so if we imagine B prime here for an 180 degree rotation, 180 degrees, here's 90, here's 180. So it's going to flip it all the way across. Okay, make a straight line as 180 degrees. That's here, this goes down below. So this is -4, -1. Your x coordinate stays the same, your y coordinate stays the same, except for they become negative. So -x, -y. Okay, this is very useful. It can save you a lot of time and thinking. Okay. One theorem here says if you rotate, if you do a reflection once and then do another reflection, I did 2 reflections, the angle between these lines might be x, and the angle of the rotation is going to be 2x. So if this is x, this blue arc is going to be 2x. It's going to be double the angle between the lines. So if this was 10, this is 20. Rotational symmetry, this is different than lines of symmetry, right? Rotational symmetry is when if I can spin an object, if I can spin it and have it land on itself. Okay, looking at this, this looks like a square, and if I spin it 90 degrees, it's going to be back on itself. Another 90 is going to bring it back to itself one more time. So this has 90 degree rotational symmetry and 180 degree rotational symmetry. We don't talk about 360 degree or anything over 180 degree rotation. You just go back. So if it has 90 degree rotation this way, it's got to have 90 degree rotation the other way. So rotational symmetry is for rotations of 180 degrees or less. Okay, so if for example, this one, I'd have to spin it all the way around. That's 360 degrees. Well, that's more than 180. So this has no rotational symmetry, where this has 90 degree and 180. This one, you could spin it here, here, and can I spin it to this one? And the answer is no on this last one, because that is over 180 degree. So this one still only has two things of rotational symmetry, and you could figure out that angle by taking 360 and dividing it by 5, which would be 360 divided by 5. Blinking for a second, 72. So that would be a 72 degree angle. This would be 144 degree angle. This one, none, and this one would have a few different ones. You could figure out that angle again. Right, there's 360 divided by 1, 2, 3, 4, 5, 6. Goes in there 60 times. This is a 60 degree angle. So this would have 60, 120, because 60 plus 60 is 120, and 180 degree rotational symmetry. One thing that's really cool is what you call an ambiogram. You can kind of see them. I find them very interesting, and you actually find them in a lot of design. So if you look at this, the Princess Bride movie cover, the movie that I liked as a kid, and I think Um, the more you liked it as a kid, the better it is as you get older. But notice that you still can read The Princess Bride, and if you flip it upside down, it still says the same thing. Okay, so these words actually have rotational symmetry. Same with the cover of the book Angels and Demons. You rotate that 180 degrees, it still says Angels and Demons. Something you can search for on the internet, ambiograms. You can rotate them. Here's Colgate, works both ways. Angels, Demons again. Here's Smiles. This one's pretty big, I guess, but if you flip your smile upside down, you might still have a smile. This love, or live, love, whatever it is, love and hate. Funny. The F is also a Y, so that when it rotates, it works. And different things, Aerosmith, coffee, pour coffee upside down, you still get coffee. Chump matches. A lot of these things are just amazing to me. This one has a line of reflection. It's not really a rotational symmetry. And thank you very much. Here's some different people's names that have rotational symmetry. The name James is still James. There's a homework assignment. Hope you enjoyed that last little bit. See you later.